Now, when we're talking about the rules of exponents, when I say the same base, okay, this word base, what I'm talking about on your notes, I want you to write this down. If you have like some number to the, let's say, 8th power, whatever is being raised to the power is called a base. The 8 is called, what is that 8 called, that number? It's called the exponent. So let's get the vocab right. Okay? Both, check this out, both the base and the exponent is called a power. Okay? So there's three things going on here. So write this off to the side after you write rule number 1. The base is what's being raised to the exponent, in this case x. The power is both the base and the exponent. And the exponent is just a little number off to the side. Let's get the vocab correct before I give you more rules. Who do we want, Castro? Okay, Castro. So that's rule number 1. Thank you. What period do you want? Actually. All right. So if you're multiplying and you have the same base, all you do is add the exponents. X to the second times x to the fourth becomes x to the sixth. Simple. Rule number 2. A power raised to another, simply multiply the exponents. Third rule. The product of items in parentheses raised to a higher power, simplify and multiply all the exponents. Simply multiply all the exponents. So look at what's in parentheses. I got a bunch of crap going on here. X to the second, y to the third, q to the second, all raised to the third power. So what did I do? I just took every power and multiplied it by the power outside the parentheses. 2 times 3 is 6, 3 times 3 is 9, 2 times 3 is 6, done. All right, rule number 4. Any non-zero number raised to the 0 power is 1. Any non-zero number. That's kind of a strange phrase. How many non-zero numbers are there? Infinite, huh? So any number that's not 0 is raised to the 0 power. It's going to be 1. And I kind of hinted at that yesterday during the table talk. You guys had a few examples where something was raised to the 0 power. And you guys are like, what do I do with that? Well, that's what you do. Just make it into 1. Even if it's a negative number, if it's to the 0 power, it just becomes 1. Strange. I'll get into that later. Good question, though. So far, so good. 5th rule. Anything raised to a negative exponent, simply take the reciprocal and make exponents positive. And we kind of touched on this yesterday also during our table talk. You guys were getting like negative exponents and you're like what do I do? Well, here's what you do. If anything has a negative exponent, you just flip it over you take the reciprocal, you flip it over the fraction bar, we're good to go. And example 6. Example 6 is kind of like example 1. When dividing with the same base, subtract the exponents. So x to the 7th divided by x to the 3rd. All you do is subtract the exponents. Cool, cool, cool. There's example 1. Let's simplify using rules of exponents. How many rules did I throw at you, Rena? How many were there? 6. We're going to use all 6 to simplify this. Okay. Let's do. So I see a bunch of crap in this parentheses raised to the power. So what I'm going to do is I'm going to use the second rule, I think. Actually, the third rule. The third rule that has, if you have a bunch of items inside parentheses and you have a power outside it, just take every item to that power outside the parentheses. So here we go. I got a 2, I got an x to the 3rd, I got a y, I got a 3, I got an x, and I got a y. I'm going to take every item to the 3rd power. So this becomes 2 to the what power? 3, huh? Because again, this is really a 2 to the 1st power. When there's no power, it's automatically 1. So 2 to the 1st power to the 3rd, just multiply the power. So 2 to the 3rd. X to the what? 9th. That's the second rule we're using, right? Power is the power to multiply. Y to the 12. All over. 3 to the 3rd. X to the 3rd. Y to the 3rd. Cool. Question so far. We're not done yet, but that's just the first step. Get rid of that parenthesis. Yes. So this was the first power, huh?
Oh, you're doing, oh.
Every item. I took every item in here. This to the 3rd power.
Oh, okay.
Yeah, okay. Good, good. A little slow. Alright. Is there any items that have the same base? X and Y, huh? Okay, X is the 9th, and I got X to the 3rd. What operation is going on between these two X's? What operation is this? Division. So the 6th rule says if you're dividing with the same base, what should you do with those exponents? Subtract those puppies. So 9 minus 3 is going to be 6. So let me rewrite everything. 2 to the 3rd power, 3 to the 3rd power, x to the 6th power. Look at, put on the numerator. See that? So x to the 9th divided by x to the 3rd became x to the 6th. I subtracted the two exponents. So far so good? Y to the what? Nice. Look at same base. I'm using the 6th rule now. 12 minus 3 is 9. Yeah? So far so good? Keep going. 2 to the 3rd power is 2 times 2 times 2. That's going to be 8. 8x to the 6th, y to the 9th. 3 times 3 is 9 times 3 is 27. Can I simplify 8 and 27 fraction? Is there any common factors there? see, is there a number that fits into both 8 and 27? Negative. Done. Final expression. Okay? I'm not going to go on to example 2 yet because what I want to show you something. I want to do the very same example. Let me clone this puppy. Do the same example but in a different way because some of you may have been thinking a different route. Watch. I'm going to get the same answer, but watch. It's a different route. So you can copy the second way down if you want. It's up to you for enrichment purposes, or you just watch me do it a different way. I'm going to use the same 6 rules, but just in a different combination. Inside the parenthesis, is there anything with same base? Inside the parenthesis. In other words, ignoring the 3 here, just looking inside the parenthesis, what has same base?
X and Y.
The X and Y is there, how much? Check it out now. Look at it. Let me come about it in a different way. Use red marker. So, inside the parentheses only, I'm just focusing inside the parentheses. I have the 2 and the 3 there. But look at this is x to the 3rd. What is this x raised to? 1, and so is this y now. So look at same base, x to the 3rd, x to the 1st. So 3 minus 1 is 2, huh? So it'll be x to the 2nd. Y to the 4th divided by y to the 1st. So 4 minus 1 will be y to the 3rd. Yeah? So I'm using the 6th rule first inside the parentheses. And at this point, now I'm going to use the 3rd rule. I got a bunch of items, I'll raise to the 3rd power, and I'll be back to over here. So look at 2 to the 3rd power, that looks familiar. X to the 6th power, that looks familiar. Y to the 9th power, that looks familiar. Over 3 to the 3rd power, that looks familiar. So we're back over here now. So just coming about it from a different perspective. Okay. You should have seen this before, either math 1 or math 2. If not, no big deal. Last example. One more example. Here we go, here we go. Here we go, here we go. There you go. Here's example 2. Copy this down. What we could do is multiply both fractions first. So 4x to the 3rd, y to the 3rd over 2xy times 5. In other words, this fraction times this fraction, which is really numerator times numerator, denominator times denominator. We can do that first and then simplify in the end. Or we can simplify each fraction first and then multiply in the end. There's 2 different ways of seeing this. Thomas. They cross cancel? Yeah. Not cross multiply, not canceling out yet. We could. And we could do that, absolutely. In other words, 2 and 4, they cancel out. This y and one of these y's cancel out. See that? Good. What I'm going to do first, though, I'm going to go from the first perspective I mentioned. Numerator times numerator, denominator times denominator. That's how we multiply by fractions. Right? Numerator times numerator, denominator. Here we go. 4 times 5, the coefficients. Coefficient times coefficient, what's 4 times 5? Thanks, guys.
20.
2 times 2. Cool. Alright, let's do this. X to the 3rd times x to the 1st. What rule am I going to use there? Same base and I multiply it. What rule is that? The first rule, which is we'll subtractively divide. Here, I'm multiplying same base, we add the exponents to be x to the 4th. Alright? X to the 3rd times x to the 1st, same base, add the exponents. Y to the, beautiful, add the exponents. Over now, here we go. We got the 4, and we got the x, and we have the y to the 2nd, right? Because you add the exponent, 1 and 1. I'm getting confident looks, and I'm getting deer in the headlights looks from some of you. Getting both here. I trust this is logical and makes sense. It's just, we're just applying those 6 rules I threw at you in the beginning. Let's do this. What's 20 divided by 4? Thanks, Darren.
5.
Sorry. Division, same base, x and x. What do I do with those exponents? Subtract, so it'll be x to the 3rd. 5 minus 2. Y to the 3rd, all over 1. Which is unnecessary. It's just going to be 5x to the 3rd, y to the 3rd. Cool, cool, cool. Before I let you go, you can copy if you want. Let me just do it one more time, a different method. You can watch or copy on your own notes. If you get this already, then you're good. Just pay attention. Don't worry about it. But if you're still struggling, I would take some more notes. Here we go. This time, I'm going to come about it from the perspective of, you know what, let me simplify this fraction first, simplify this fraction first, and then multiply in the end. Up here, I multiply first, and then simplify it. I'll simplify, then multiply. See if that helps. All right, let's see. 4 divided by 2 is going to be 2 over 1. X to the 3rd, x to the 1st. Same base division, I subtract. That's going to be x to the 2nd. Same base division, I subtract. That'd be y to the 2nd. Notice. So the first fraction turns into this. That fraction. Times 5 over 2. That doesn't simplify, so I'll just put the 5 over the 2 here. X, I can't simplify that with anything. But look at y to the 2nd and y to the 1st. I'm dividing, and I have the same base of the y and y, so I'll subtract, so it'll be y to the 1st. So I simplified both fractions. This fraction simplifies to that. This fraction simplifies to that. Now I'll multiply. Fraction times fraction. Numerator times numerator, so I'm going to have 5, or 2 times 5 is 10. X to the 2nd times x to the 1st is x to the 3rd. That looks familiar. There it is. Y to the 2nd times y to the 1st. That's y to the 3rd. That looks familiar. There it is. Over denominator times denominator is 2. 10 divided by 2. Put back over here. It's 5. So just a different way of seeing it.